Hi everybody, welcome to Mathix. Today we will be covering the counting principle, which comprises of addition and multiplication principle, and we will be taking examples to understand it very clearly because these two principles are the backbone of the counting and which we called as PnC, permutation and combination, and permutation and combination is the very building block required for the classical probability. So for both these two chapters, these two principles are very important, and you will just need to understand it very clearly because any confusion in it will lead to making it wrong. So getting over to the concept part, counting principle, addition and multiplication. Before telling about the counting principles, I would like to take your attention towards n factorial. It is also represented as this. So what it is? N factorial means n into n minus 1 into n minus 2 dot until we get 1. For example, like 4 factorial is what? 4 into 4 minus 1 into 4 minus 2 into 4 minus 3, and yes. So basically over here what we get, 4 into 3 into 2 into 1, which is 24. 5 factorial is what? 5 into 4 into 3 into 2 into 1, which is basically 5 into 24, which is 120. One more properties can be remember, like n into n minus 1 factorial. It is n factorial. You can see over here that 5 factorial is what? 5 into 4 into 3 into 2 into 1. This is what? 4 factorial, right? This is what? It can be like considered as 5 into 4 factorial, right? Yes. So now moving on to our main part, that is addition and multiplication principle. Addition principle is also called as OR rule, and multiplication principle is known as AND rule. We will understand via an example. Suppose we need to move from city A to city B via city C. I mean, there is an intermediate city in between A and B, that is city C, and there are like three ways, three roads that take you from city A to city C, and there are two roads that take you from city C to city B, and there is also two roads that directly connect city A to city B. So we need to find total number of ways in which we can move to city B from city A. So currently we are in the city A and we need to move on to city B. So first let's go by our very first thought. If you are beginner in this, so you can just go by counting all this simply. So Like we can go from, let me mark this path. This is A, this is B, this is C, this is D, this is E, this is F, this is G. So we can, the very first idea that came to my mind, if I am a beginner, then we can basically go from city A to city B by this path, F path, and then in by G path. So there are two ways, right? Okay, there are two ways that directly I can go from city A to city B. Now, if we have to also go to city C in between city and B, so we can we can choose path A, and when we will be in city C, so we can take either path D or path E, right? Or we can take path B, and then when we will be in the city C, we can take path D or path E, right? Or similarly by taking path C and then D, or C and D. So basically from over here we get 6 ways, right? And 2 ways that directly I can go from A to B. So there are total 8 ways, right? So this was the very first thing that any beginner will do. Like he or she, he will directly jump into counting the number of paths. But when the number of path that is in between these cities increases, so it will be a hectic task to write all these paths and then determine the number of ways, right? It will be such a tedious work to do this. So we will now see how to do it in a more efficient ways that is also applicable in it does not depends like for a smaller value or larger value. So this denotes the number of path, right? So from city A to city C, we can go by like say case 1 via B. Oh, sorry. Here we have taken B and here we have taken C. Via C, and case 2 not via C. Means we are not moving from city C and we are directly going from city A to B. So the case 2 is very simple. First do that. Case 2 is very simple. So for moving A to B there are two ways, and that's simple. But for case 1 we can move to city C from A to C in how many ways? Like there are three paths, so there will be three ways. I can take any one of these routes and go to city C from A, and and then when we will be in city C, we want to go to city B. We have two ways, right? We can take either this or this. So we have this 6 ways, right? So total we get 8 ways, and you can clearly see that by our basic counting also we get 8 ways. But you will be thinking that the counting was also not very tedious. Yes, it was not tedious because the number of paths were very less. But see, the number of paths is like for moving from city A to C, it's 5 path and then 3 path. So now let's calculate, and there are also uh, 4 path that directly connects to city B from city. So the case 1 was directly A to B, so there are 4 ways. Case 2 is how many ways? 1, 2, 3, 4, 5 ways, and then 3 ways. So it is 15. Means total we have 19 ways. And if in the question it is just asking the number of ways, um, the number of ways in which a person can go from city A to city B. So here it is asking only the number of ways. So it is not a smart idea to just first write all the paths and then calculate and then I mean then count the number of ways. So this is not a smart idea. Also, generally in the question it is asked about how many number of ways. So if it is asking only about the number of ways, then I think this is the best. And you can also see that we just need to do one multiplication and then addition, right? So this is basically piece of cake for a long like if the number of paths are also more, then also it will be very easy because we need to just only multiply and then add. If there is the possibility of case 1, case 2, case 3, then we will be adding all the cases. Now let me take one more example. Then I will focus on the part like why addition is also called as OR rule and multiplication is called as AND rule. So suppose we have 6 students, three girls and three boys. We need to make committee of 3 students. So how we will be approaching this problem? Just see. We need to have 3 students in our committee. So three students can be either 3 girls or 0 boys. The very or 3 boys and 0 girls, and 2 boys, 1 girls, 1 boy, 2 girls. Right? These are the 4 possible cases. I would say cases because here also we will be getting some committees and here also and similarly over here also. So let's do it. Case 1 was 3 boys and 0 girls. We had B1, B2, B3, G1, G2, G3. These were the 6 students in class, I would say, and we need to form a committee of 3 members which consist of only boys. So if we have to include only boys, so this is only three, like there is only single which in which we will be including all the boys. And for no girls, like selecting none of them is one possibility, right? Wait, I will write over here. So selection of 3 boys, out of 3 boys it will be one basically, and for selecting 0 girls it will be one. You might be thinking like selection of non-girl is how zero. Like consider when we are selecting something, right? When we are selecting something. So not selecting something is also a possibility. Are you getting it? Wait, let me make it more clear to you. Like when we are selecting, for example, 2 girls, we have selected 2 girls. But when we are saying none girls need to be selected, so we are saying all the girls to be none. So this is also a possibility, right? Just like selecting all girls. Just like selecting all girls is a possibility, selecting none girls is also one possibility. So it is one wish. Now, oops, just so our case 2 was 3 girls and 0 boys. So if you think carefully, this is also the similar case, right? Because we need to select 3 girls and there are only 3 girls present. So there is only one possibility, and selecting none boys is also one possibility. So 1 into 1 means one wish. And then case 3 is 2 boys and 1 girls. So out of B1, B2, B3, G1, G2, G3. Group of 2 boys like B1, B2 can be selected. B2, B3 can be selected. B1, B3 can be selected. And G1, G2, G3. Right? So we can select two boys in 3 ways. Suppose these students are a packet. They are in a bundle form. Boy 1 and boy 2 are in a bundle, boy 2 and boy 3 are in bundle, and these are the different bundles. And we need to choose one bundle which comprises of 2 girls. So basically out of 3 you are choosing one. So you can choose either this bundle or this bundle. There's 3 possibility. And for choosing 3 girls also there are simply 3 ways, because you can choose either this and either this. So it is 9 ways. Similarly, if you look closer, so case 4 is 1 boy and 2 girls. It is basically the same. B1, B2, B3, G1, G2, G2, G3, G3, G1. So selecting one boy is either this. So we have 3 ways. Either selecting 2 girls. So either this packet or this packet. So we have 3 ways. So 9 ways total. So finally we get total number of ways, adding all the cases, because in all the cases we got some number of committee. Like from the case 1, that was all 3 boys and 0 girls. We have got one committee which comprises of all the boys, and 3 girls and 0 boys. It was also one committee that was formed, and for 2 boys and 1 girl, 9, and then 9. So basically it is 20 different committees that can be formed. Now let me tell you the importance of and or. For example, in our previous example that we have taken, committee of 3 members, committee of 3 members. So we had a case that was 2 boys and 1 girl. Means we need, for example, we need to sit these 3 members on this chairs, right? And say the ranking of the chair is not like all the chairs are identical, and the position of the chair is not it does not depend. So say we need to maintain two boys and one girls. Means suppose we have one boy over here and boy over here and girl over here. Because if we are saying like or means basically you can take a closer look over here that if we will not market market compulsory like if we will take B1 B2 and this box not committee. To complete a committee, we need to have three members. So this place must be filled. So we can say that filling place 1 and filling place 2 and filling place 3. You got the meaning? But when we are making cases like we had two boys, one girl, three boys, zero girls. So here we have boy, boy, girl, and here we have boy, boy, boy. So this is also forming a committee and this is also a forming committee. So we will be adding it, right? Because it is complete committee and it is also a complete committee. So we will be adding. I hope you uh, got the importance of the and all because this is very important principle and this marks the backbone of the PNC. I have explained all these things. Now let's do some question and you will feel confident after doing it. So the very first question says that determine the number of four-digit positive integers without repeating digits. Means we are not allowed to repeat the digits. Means 9981 is will not come under our answer, right? So there are total 10 digits with which we can form the number. It includes 0, 1, 2, 3 and 9. So the thousands place we since we need to form a four-digit positive integer, we cannot put 0 on the thousands place because then it will be three-digit number, not four-digit number. So here we cannot put 0. 0 cannot be put over here. So we have left over with 9 different digits. So how many like on the thousands place? Either 1 can go, either 2 can go, either 3 can go, and etc. Either can 9 can go. So basically we have 9 ways over here. Similarly for the hundreds place. Now suppose we have taken 2 over here means this 2 is fixed. Consider it to be fixed means so if 2 is fixed now we have 9 digits remaining because now we can take 0 over here means this 0 is valid because 0 can come in the middle of the digits, right? And but not on the very first place because otherwise it will lead to the lesser number of digits means it will not be a four digit number. So for the hundreds place we have 9 digits possibility, right? So thousands place and hundreds place and for this tens place for the like we have chosen two like again say for example we have fixed over here 1. So out of 10 digits now we have chosen 2 means 2 are already done. We cannot repeat the digits so we have only 8 digits to use. So on this tens place we can have 8 digits, right? And on this ones place again 3 digits are chosen for example over here 7. let's let's say 7 is chosen over here. So out of 10 digits 3 digits are already been taken. So the last ones place can be filled in 7 ways, right? Because there will be 7 digits left. So number of 4-digit positive integers without repetition will be this product, which is basically 4536. Now moving on to the next question. In how many ways can we draw a sequence of 3 cards from a standard deck of 52 cards? Here a word sequence of 3 cards. It means choosing first card, then second card, and then third card. In question, sometimes it mentioned that to replacing the cards one by one. Means I have chosen the first card and then putting it back in the deck. Then we are choosing second card and then putting it back in the deck. And then third card and putting it back in the deck. So we are not doing this thing. We are choosing first card, then second card, and then third card. So for choosing the very first card out of 52 cards, we have 52 ways. First card can be chosen in 52 ways because we can choose any one of the 52 cards. All the 52 cards are different in cards. So we have 52 ways to select the very first card. Now we have chosen one out of 52 cards, so we will be left with 51 cards, and we need to choose one from 51 cards. So it will be one possibility. And the third card, since we have chosen one card over here, one card over here, so we will be having only 50 cards left with us, and choosing one card from 50 cards we can choose any one of the 50 cards. So this is the total number of ways in which we can draw a sequence of 3 cards. So multiplying all this, we will be getting 132600. Yeah. So this is the answer. Moving on to next question. This question says how many different license plates are there if a standard license plate consists of 3 letters followed by 3 digits. Means our license plates comprises of 6 characters, letters and numbers. The very first 3 characters are letters and the last 3 characters are numbers. So let me mark over a partition. So the very first position of the letters we have 26 possibility, because we can choose any one of the 26 letters in our English alphabet. So we can choosing one from 26 is 26 ways, right? Because for example, we have three books of uh, science, for example, physics, chemistry, and biology. We can choose either this book, and this book. So from 3 books, we are choosing only one book. So there are we can choose either this book or this book or this book. Means 1 plus 1 plus 1 in 3 ways, right? So 26 ways are there to fill this first position. For the second position, again we will be having 26 digits. Think why? Because here it is not said that all the letters will be different. It is not saying that, right? So we have a freedom to choose any of the alphabet. So we have 26 ways, and the third letter is also 26 ways, and this first number we have 10 ways because we can choose the zero in between, right? Means it is saying, for example, ABC 095. This is a possible license number. So we have over here 10 ways. Again, for this we have 10 ways, and this we have 10 ways. So total weight is 26 cube into 10 cube, which is 260 cube. You might be thinking that why we have not added done this and then done this and then adding this. We cannot add it, right? Because it means like ABC and then 095. This must be over here to complete the license number, right? So first letter and second letter and third letter and the first number and the second number and the fourth and the third number, right? I hope you understand this. Um, I would like to give a problem that you can comment in the comment section. Um, Comment in comments. You can answer your. You can answer in comment section. In India, we have 10 digits number, mobile number, 3, 6, 9, 10. In India, we have 10 digits number, mobile number, right? So you need to find out how many different numbers, how many different mobile numbers can be formed. Different mobile numbers can be generated. You need to answer in comment section like how many different mobile numbers can be generated. Please note that if we will put 0 over here, then it will not a 10 digit number, it will be a 9 digit number. So we cannot put 0 over here. I hope I have given enough hint. Now you have to try it and answer in the comment section. Moving on to the next question, we have a professor had 7 books on discrete maths, 5 on number theory, and 5 on abstract algebra. So he had 7 books of discrete maths, 5 on number theory, and 4 on abstract algebra. In how many ways can a student borrow 2 books? Not both books are of same subject. So, like for example, say book 1 and book 2. Um, Book 1 can be of discrete math. Let me name it to be discrete math to be A, book number A, book number B, and book number C. So book 1 can be A, book 2 can be B, case 1, case 2 will be book 1 can be B, book 2 can be C, case 3, book 1 can be A, book 2 can be C. Since here it is saying for only borrowing 2 books, we are not considerate about choosing book 1 as like I mean choosing book BA. It's same as choosing book AB, right? Because we are getting the 2 books. Ranking does not matter like this is book number 1 and this is book number 2. In this question, ranking does not matter. So we will be having only these 3 possibility. If ranking matters, then we will add 6 possibility. Then we will also including BA and CB and CA. Since here it is not applicable, we will be not doing that. So we will have 3 cases. The case 1 says uh, one book of A, one book of B, one book of A and one book of B, right? Here it will be and not or because we need to choose 2 books. So if we will choose only one book, our action is not complete. To complete our action, we need to choose another book also. So and also signifies of mustness. Like it is a must to select the another book. So choosing book A, we have 7 A books. So there are choosing one book out of 7 books is one wish, and choosing one book of B, we have 5, so it will be 35. Case 2, one book of B, one book of C. One book of B means 5 wish, and one book of C is 4 wish, means 20 wish. Case 3, one book of A, one book of C. So one book of A can be chosen in 7 ways, and one book of C can be chosen in 4 ways. So 28. Total number of ways a student get borrow 2 books will be adding all these cases, because all means case 1 is complete in itself, case 2 is complete in itself, and case 3 is complete in itself, because our action is complete, we have chosen 2 books, right? So adding all these cases, we will be getting 35 plus 20 plus 28, and it is 83. Moving on to the next question, and this is our the last question that we will be doing on this topic. Find the number of positive integer not exceeding 999 that ends with 7. Okay. So since here it is talking about positive integer, it is not mentioned about 3-digit number or 2-digit number or 1-digit number. So we will have 3 cases, right? Because case 1 is 1-digit number, case 2 2-digit number, and case 3 3-digit number, right? So what our condition that end with 7. So basically means case 1 is very simple, since we have only one digit that ends in 7, it will be only 7, right? So we have one ways only, I would say one number only, and since we need to have 2-digit number, I have left this is ones place and this is tens place. Ones place is fixed because it is saying that it should end with 7, but the tens place has how many ways? Think of it, has 9 ways, because we cannot include 0 here. 0 cannot be included, otherwise it will be a 1-digit number, that is 7, that we have already counted in the case 1. So we cannot include 0 over here, so we have only 9 ways, either 1 2 3 4 5 6 7 8 9. Note that we can also put 7 over here. It is not saying anything that the digits should not repeat or anything. So we can put 7 also. Okay. So we had 9 ways, right? Because we can put any one of the digits from 1 to 9. So there are 9 numbers. And for the third digit, 3-digit number, since we have 7 fixed over here, for the tens digits, tens digits can be 0 also, like this is valid. 0 can go on to the tens digit. So here it will be 10 possibility, but the 100 digits cannot be 0, because if it is 0 then it will become a 2-digit number. So we have over here 9 possibility. So 90 numbers can be formed. Totaling all total numbers will be how much? Adding all these cases, because all these cases are complete in itself, all these cases are satisfying the condition that end the number should end with 7, right? So adding all the cases, we get 1 plus 9 plus 90, which is 100. This was method 1 to solve this question. I would tell method 2 also, because in permutation and combination it is always advisable when we are solving, when you are practicing, you should have a multiple thought, and it will help you a lot too, because it is not always that a question can be solved in a single way only. Mathematics is full of ideas. If you think carefully, you can solve a question in several different ways, right? So I will try this question in another method also. So over here also, over here only, method 2. Since we need to form a positive integer, not exceeding 997. So, and it is given that our n digit is 7. So in this we will be not forming cases. We will be doing it simply. So our unit digit is fixed. We cannot change it. So no issue. But this both two, like this 10 digits and 100 digits, it can be filled in 10 ways and 10 ways. Please note, I'm not saying that 0 can be placed on the hundreds place to form 3 digit number. 027 is only 2 digit number. It is not a 3 digit number. It is not a 3 digit number. But if we have included over here 10 possibility and over here also 10 possibility, then how we are satisfying the condition that is required? So let's see. Suppose our hundreds place is 0 and our tens place is also 0 and our unit place is 7. Both these are 0, right? So this is a valid case, right? Because it is similar to our case 1, which says one digit number having 7, right? Now take the our this hundreds place to be 0 and this is non-zero, this is non-zero and this is 7. Since this is non-zero and this is 0, it will be 2 digit number, which is similar to our case 2, right? Because in case 2 we are not including over here, uh, not including over, not including 0 in this, right? So this is non-zero, and if it is 0, 7, say this is 6. If it is 0, then also the case is valid, right? Because 607 is a 3 digit number and it is a valid case. So I hope you understand the importance of the multiplication and addition principle. These are the most important counting principle that are very fundamental, I would say, because there are no formula required for counting. You have seen these are basically adding and multiplying things, and it is very important, since I have said in the starting only. It is the backbone of the permutation and combination. I hope you have understood all the concept, and you have understood the question that I have solved. If you have any query, you can comment down in the comment section, and if you have any genuine feedback, you can leave it in the comment section. Thank you. I hope you enjoyed.